Hello everyone. So in this video of chapter electrochemistry, I'll be talking about nickel-cadmium battery, mercury battery, electrochemical series and its applications. Nickel-cadmium battery or NICAD storage cell. Nickel-cadmium cell is a secondary cell. In other words, it is a dry cell that can be recharged. Anode of NICAD storage cell is cadmium metal. The cathode is nickel 4 oxide or NiO2 supported on nickel. The electrolyte solution is basic. The electrode reaction and overall cell reaction are cadmium is reacting with two hydroxyl ions to give you cadmium hydroxide and eliminate two electrons. It is oxidation reaction, whereas NiO2 in presence of water will take up these two electrons to convert into NiOH whole twice and eliminate two hydroxyl ions. On adding these two equations, we'll be getting this net cell reaction. The reaction product at each electrode is solid that adheres to electrode surface. Therefore, the cell can be recharged. The potential of cell is about 1.4 volts. The cell has longer life than the other dry cells. It can be used in electronic watches, calculators, photographic equipments. Now, mercury battery. Mercury battery is also a secondary dry cell and can be recharged. Mercury battery consists of zinc anode and it is amalgamated with mercury. The cathode is a paste of mercury and carbon. The electrolyte is strongly alkaline and made up of the paste, potassium hydroxide and zinc oxide. The reactions are, this is the oxidation reaction where amalgamated zinc is reacting with hydroxyl ions to give you zinc oxide and water, and two electrons are eliminated. These two electrons will go to cathode where mercuric oxide and water is also present to give you mercury and two hydroxyl ions. This would be the net cell reaction. The overall cell reaction involves only solid substances. There is no change in electrolyte composition during the operation. The mercury battery therefore provides more constant voltage, that is 1.35 volt, than the Leclanche dry cell. It also has considerably high capacity and longer life than dry cell. Mercury dry cell finds use in hearing aids, electrical watches and pacemakers. Electrochemical series or electromotive series. The standard potential of number of electrodes have been determined using SHE or standard hydrogen electrode, and these electrodes with their half reaction are arranged according to their descending standard potential, and this arrangement is called electrochemical series. This is the arrangement of different electrodes with their half cell, and these are arranged in the decreasing order of the standard potential, and the arrangement is called as electrochemical series. This is the series, this is the half of the series, and this is another half series where you will see the metal with their metal ions along with their E0 values. Now, what all are the key points of electrochemical series? The half cell are written as reductions. The oxidizing agents and the electrons appear on the left hand side of half reaction, while the reducing agent are showing at the right hand side of the reaction. And below hydrogen electrode, you will get to see the negative electrode potential start increasing. See, hydrogen has 0 value, and below hydrogen the negative value will start appearing. The E0 values apply to the reduction half reaction that occurs in the forward direction as it is written. More positive E0 value for half reaction indicates the greater tendency to occur in the forward direction and greater tendency of a substance to get reduced. On contrary, the lower E0 value of a half reaction corresponding to the greater tendency to occur in reverse direction or substance to get oxidized. What all are the application of electrochemical series? Number one application is relative strength of oxidizing agent. The species on the left hand side of half reaction are oxidizing agent. E0 value is measure of the tendency of species to accept electrons and get reduced. E0 value measure the strength of the substance as oxidizing agent. Larger the E0 value, greater the oxidizing strength. The species which are at top of the series are strong oxidizing agent. As we are moving down, E0 value and the strength of oxidizing agent both will decrease. Another application is relative strength of reducing agent. The species on the right side of half reaction are reducing agent. As we are going down, the E0 value will keep on decreasing, and when they are decreasing, the reducing strength will also increasing. Third application is to determine the spontaneity of redox reaction. The redox reaction in galvanic cell is spontaneous only if the species with higher E0 values is reduced and the lower E0 values is oxidized. The standard electrode potential must be positive for the cell reaction to be spontaneous under the standard condition. If the question is like, at the standard condition, silver ion oxidize metallic magnesium. So what would we write? Magnesium will oxidize to give you magnesium ion and 2 electrons, and these 2 electrons would be accepted by silver ions to give you silver metal. This would be the overall reaction. E0 value of magnesium is minus 2.37 volt and E0 of silver is minus 0.8 volt. By putting in formula, E0 cell is equal to E0 of cathode minus E0 of anode would be equal to 0.8 minus in bracket minus 2.37. You will be getting positive value which is 3.17 volt, because here E0 cell or cell potential is coming positive. That is why the reaction is spontaneous. Thus silver ion oxidized to metallic magnesium. This is how we used to determine the spontaneity of the redox reaction with the help of standard potential given in the electrochemical series. Thank you.